just stop for a second, write down these steps for doing derivatives, and then we'll give you some examples on how to do them. So go ahead and stop the video and write down those steps. Now, when you do the derivatives, we're just going to follow the steps here. We're going to come up with an equation like this, so this will get on your calculator. And if I wanted to find the first derivative of this, so in this case, it would say something like y equals this equation. The first derivative, we put this little apostrophe or prime after it, and we're just going to follow these steps. And it says multiply the exponent by the coefficient. Well, the exponent's this little number up here. The coefficient's the big number, so I'm going to take 3 times 4, and it says for me in part A to write down that number. So 3 times 4 is 12. In part B, it says to rewrite the letter, so I'm going to put down the x. And in part C, it says to lower the exponent by 1. Well, 3 minus 1 gives you 2. Okay? And then we just go to the next term and we do the same thing. And I should have made this in green as well. And so I'm going to take the exponent, which is 2, multiply it by the coefficient, which is also 2, and write down that number. Part B says to rewrite the letter. And then part C says to lower the exponent by 1. Well, 2 minus 1 gives you 1. So then I'm going to go to the next term. Well, the next term doesn't have an exponent, but it's understood that it's a 1. So I'm going to take 1 times 1 gives you 1. Then it says to rewrite the letter. Well, if you lower the exponent by 1, 1 minus 1 gives you 0. And any number to the 0 power is 1. So 1 times 1 simply gives you 1. So that just goes away. And then lastly, this 2 here, when it comes down, there's no exponent or coefficient to multiply by, so you just sort of drop the 2. So this right here would be considered our first derivative. Now, if you want to do a second derivative, the second derivative is the derivative of the first derivative. Wow, that's a lot. So we're just going to do the same process over again, but I'm going to now use the screen line here and take the derivative of that. So follow the same steps again. 2 times 12 gives you 24. Rewrite the letter. Drop the exponent by 1. 2 minus 1 gives you 1. Then I'm going to take the 1 times the 4. That gives you 4. Drop the exponent by 1. Well, x to the 0 power, once again, is 1. So therefore, that just gives you 4. And then the 1 gets dropped. Okay? So that's how you do derivatives. Now let's discuss what we use them for. In physics, we use calculus a lot like this to figure out the velocity and acceleration if you are giving a distance over time graph. So let's say this is your graph right here. And we're going to put distance on the y-axis. And we're going to put time on the x-axis. And instead of having x's and y's in our formulas, let's go ahead and put distance and times. So I'm going to take this data that you see in the chart right here, and I'm going to put it in my calculator. So I'll bring my calculator up. And the way I do this is I go into stat. Come up here. It's not letting me click the buttons on here, so I'm going to come to the computer. If I hit the stat, I guess it would be good if I turned it on. And you go into stat. If you then go to enter and edit, you now can type in all the data. So I typed in all that data on the computer. If you want to go ahead and stop the video and put this in your calculator as well, that'd be a good thing to do. Now what I want to do is I want to see what this graph is going to look like. So if I go to hit the graph button over here, let's do second stat plot. I need to turn on those graphs. So I'm going to hit the first one here and just turn this one on. Let's, uh-oh, what did I just do? Let's turn this one on again. And then if I click on number 1, let's go ahead and come down here, connect all the little dots, hit enter. And then if I graph this, I'm going to zoom around those particular stats. If you notice, you have a nice little curved line. Well, what I want to know is I want to know what is its velocity at any given time, and I want to know what is its acceleration at any given time. So I'm going to come up here and I'm going to get the equation for that particular graph, and if I hit stat, go over to calc, And since it's a since it's a curved line, I'm going to come down here to number 5, which is quadratic regression. And when I hit the answer, whoops, I just screwed that up. Do that again. I'm clear it all out. I'm going to hit stat, go over to calc. It's going to go down to number 5 for quadratic regression. If you notice, it gives me this equation of 1.5x squared plus 2x plus 3. So I'm going to write this down. Unfortunately, my calculator disappears when I write it down. So I'm going to come up here and I'll put y equals 1.5x squared plus 2x plus 3. Now, if you remember, I just said that all the distances were on the y-axis and t's were on the time. Time was on the x-axis. So I can change all my y's to d's, and all my x's I can change to t's. And if I wanted to find the distance at any particular time, oops, I'm going to change that one to a t. I could simply put in any time in here, and it would give me what distance I went. So if I did 1 second, I could do 1 squared plus times 1.5. That would give me 1.5 times 1 squared. And then I'd put 1 in for this t here. And then you simply add them all up. So I got 1.5 squared, which I have, I think it's 2.25, plus 2 would be 4.25. So I think it's going to end up being about 7.25 if I did the math right, which I don't know if I did or not. But anyway, that's how many meters it would be. Now, let's say if I wanted to find out the velocity. Now, in your math classes, once again, you've been learning how to do derivatives, and I am not sure why this works. I just know that it does. So if I want to find the first derivative of that equation, the first derivative will equal the velocity. And so what I'm going to do is I'm going to do that process we just did. 2 times 1.5 gives you 3. Rewrite your letter. Drop the exponent by 1, and you get 3t to the first power. Then do the second term. Well, 1 times 2 is 2. The t gets lowered to the 0 power, and so therefore it goes away, and so you're left with 3t plus 2. So if I want to find out how fast I was going after 1 second, all you'd have to do is put in a 1 for the t. So I could take 3 times 1 plus 2, and that means I'd be going 5 meters per second. And so once again, the first derivative gives you velocity. But what's great is the second derivative gives you acceleration. So if I wanted to figure out the acceleration, I'm going to take the second derivative of that first equation. Well, remember, the second derivative is the first derivative of the first derivative. And so I'm just going to take the derivative of this one up here. So I'm going to take the 1 times the 3. Lower the t to the 0 power, well, that goes away, right? So I'm just going to erase this. And so my acceleration in this case is always 3 meters per second squared. And so what we can end up doing, we can get some lab data, and we're going to go in and figure out what the acceleration due to gravity is. So this is how you do derivatives. Now you'll have a worksheet that I gave you that says derivative practice problems. And there's one of them on there I want you to be really careful of, because, and erase all this, let's say you're given this equation right here, and where distance equals 2t plus 3, okay? Well, when you find the first derivative of that, which is the same thing as velocity, you're going to end up getting 2. Because remember, the t goes down to the 0 power, and it just goes away. So your velocity would be 2 meters. There is no t. So you're always going 2 meters per second. Well, if you're always going 2 meters per second, that means you're not speeding up or slowing down. So your acceleration, which is your second derivative, well, look around. Let's take the derivative of the first derivative of the first derivative. Well, this 2 doesn't have a letter to it. So that means it ends up being 0 or nothing. Well, if you're not changing speed, you're going 2 meters per second all the time, you're not changing speed, so your acceleration is actually going to be 0 meters per second squared. So don't let those easier graphs confuse you if the original formula only has 2 terms in it. Hope this helps.